everyone. I'm Auke Haanstra. And well, you see here my partner on top of the screen, the unicorn. Her name is Bubbles Starbreeze. I'll just call her Bubbles during the presentation. And wow, you see the colors on her manes and on her tail. She's just one beautiful beast. I have a question for you. Who does think she's modular? Nobody? Well, I'll just show you something here. So, we'll give her another leg. Oh, it turns red. And she's got a magic ability, Fire Blast. We can give her yet another leg, a blue leg. And now she's got another magic ability, Water Shield. So she's very modular, actually. Well, and that's not all. She's actually modular to the bones because she's built with Spring Modulith. She's built with Java modules, and what not actually. Well, she's actually an event-driven unicorn that's got hexagonal architecture. She's got object orientation and even DDD. Well, that sounds a bit nasty, but okay, let's move on to the presentation. So it will be about going from a monolith to a modulith, unlocking the power of hexagonal architecture in Java. Let me introduce myself. So I'm Auke Haanstra, consultant at Pen Company. My expertise is test-driven development and hexagonal architecture. I've got 8 years of experience in Java development. And with Pan Company, I have 35 colleagues in the Java competence. So let's move to the contents of this presentation. First, I'll be setting the stage by introducing the monolith. Then we'll jump to the modulith. We'll look at hexagonal architecture and Java modules. We'll look into an example, the Unicorn app. Well, we'll skim a bit over hexagonal architecture and testing. And then we'll look at hexagonal architecture as an enabler technology. And finally, we'll look at migrating with Spring Modulith, going from the monolith to the modulith with the Unicorn demo app. So when we're thinking about the monolith, for most of us, what will pop to the mind is actually what we see here. Yeah, it's the metaphor of the big ball of mud. So we've all been there. The big ball of mud has a lack of structure, of architecture. It's got a lack of modularity. There's messy code. It's hard to test. And there's a resistance to change. It's very tightly coupled. So are microservices the solution? Well, sometimes, but often they also bring too much complexity. Often a microservices first approach is a bad idea because microservices bring much complexity, operational overhead, performance issues, and they can degrade to what you see here, actually a distributed ball of balls of mud. Also, you need to have the context boundaries right at first, because if you go refactoring over microservices boundaries, well, you're going to have a hard time. So hexagonal architecture to the rescue. Hexagonal architecture provides a simple and well-defined architecture that emphasizes the use of ports. And those ports are APIs for the adapters and the application. Those are components of the architecture. And these port interfaces can be used to run tests against, and they decouple the application from the domain and from the application and the domain, they copy it from the technical details. It also provides technical flexibility, an excellent testability, and maintainability. And actually, in combination with Java modules, we're having a modulith. So let's see if this works. Yeah. Okay, we'll use this one. So what you see here, in the middle, there's the hexagon of the hexagonal architecture. That's where it derives its name from. So you see 6 sides. So this is the application core. That's the most important thing in the application, in this architecture. And at the outside, you see the web adapter, an external system adapter. You see all kinds of different adapters. And you see the flow going here towards the application core. There you see the flow going outside of the application core. So you've got a web adapter, there's some web requests coming in. It goes via an input port to the use case. Well, that's actually the implementation of a use case is usually a service. Then it goes to an output port via the output port to the persistence adapter, for example. So that's actually what you have with 3-layer architecture also. But here it's just organized via the ports and adapters pattern. So what you're also seeing here is an arrow in the other direction, and here too. That's actually what we call dependency inversion. So, and in the middle, you see the use cases use entities. So there's the domain model at the middle of the hexagon. So if we look at this dependency inversion in more detail, what is dependency inversion? It is, this is not dependency inversion. This is what you usually do. So you have some upstream class. It's got to do something. So it actually has a dependency on the downstream class to which it delegates some subtask. So this upstream class is dependent on the downstream class, and the flow of control goes towards the downstream class. With dependency inversion, you turn this around. So here you have the upstream class, and it's not dependent on the downstream class anymore. It's dependent on the interface, and the downstream class, in turn, is dependent on the upstream part. So what you do is you define the interface near your upstream class. So within the architectural boundaries of the upstream class, you can even define it as a static nested class, for example, in the upstream class, as a static nested interface, I must say. So you have the dependency pointing in the other direction of the flow. And that's what we call dependency inversion. And in this way, we can really decouple things. And that's what hexagonal architecture uses. So let's do some hands-on work here to make it more clear what hexagonal architecture is. Let's do that with TDD. All right, so here's a project. Well, there's not much in it. Let's get the structure which we just shown in the diagram into this code. So let's just make packages here. So first in our well, it's actually called Modulith, but we'll only do hexagonal architecture just now. So what we'll be making first is an application package. So that will be the application core. We'll be making an adapter package, or adapters will go in that. And in the application core, you would have a domain model. So let's just call it domain. And what more? You would have, of course, use cases, use case implementations, services. Oh, I put that accidentally into let's just see if we can move it. Yeah, I think it worked. So now we've got the use case also in the application. And let's see, we missed one element. Of course, the ports. Let's call it port. So both the adapters and the ports are also separated in incoming and outgoing variants. So what comes in from a web adapter, that's of course incoming, and what goes out, for example, to persistence, that's outgoing. So we'll just make an in package here, and let's also make an out package. Out. Yes. And for the adapter, we'll just do the same. Let's just make in, and let's make out. And actually, when we've done this, we've already made the whole structure for a hexagonal for a hexagonal application. So it's actually a quite simple structure. So we can now go ahead. I've got a bit of a boilerplate already set up. I have to do a copy paste, okay. So, yes. And then let's check that out. Okay. So let's look if that works, yeah. So now actually we wanted to do this with TDD, so we've already got the test here. Well, some things are not yet present. So if we look here in the use case package, we already have a service, a use case implementation. We also have some manual wiring already set up via context classes. So there's an application context which wires up everything in production. And for the test, we have a test context, which in turn injects into the application context. So let's get this test working, because we're working test first here. Let's see, unicorn use case. So we don't have that yet because we only have the implementation yet. Let's make an interface. So we want it in the main sources, and we want it, of course, in the ports. It's an incoming port. It goes into the application. Yes, that's fine. Right, so we have that. Let's see if the service now implements it. Well, not yet. Let's do the proper import there. Yes, that worked. And here too. Okay, let's see. In the use case, there's not a method get unicorn yet. So we'll be getting a unicorn. So what we're going to do, I should first say, we're going to test whether we can get a unicorn from the use case. So the use case is the port into the application core. It's the API, as it were, to the application core. So we're going to query that API, and then we are going to assert that the unicorn we get is actually the unicorn we expect with the correct UUID. So there's something not yet set up right here, so let's just jump into that. Well, because the import is not there yet. And here there's also something. So here's also a bad import. Oh, it's just a bit of setup yet. Let's look at the use case test again. So that's fine now. But we've still got some compilation errors. Apparently this doesn't work because we don't have a unicorn repository interface yet. So let's make that one. So we're going to create the interface. And we already made an interface for an incoming port. Now we're going to make an outgoing interface, an outgoing port. So yeah, this, so incoming is the use case, outgoing is the repository. Let's look whether we've got compilation errors now. Okay, let's go to the service. So we have to import classes. It's a bit annoying, all these things. Cannot find the declaration, create a method. Yeah, we're going to create it in the unicorn repository. So now we've actually declared the APIs on the application core. Those are the ports. So we can go back to the use case test and run the test, see whether it works. I don't see any compilation errors. So let's see. Yeah, it works. But we haven't got an implementation yet, right? So I cheated a bit. I already put an implementation in place, a very simple repository implementation, namely a method reference to the unicorn constructor. So let's take that away. And well, now we want to make a real implementation. So let's just say new unicorn repository. Now let's say in-memory repository, because that's what it is, of course. Okay. Yes, create class. Well, let's see where we're going to create it, not in the test sources, in the main sources. And this is an implementation of a port. So we're going to put it now in the adapter. It goes, the flow goes outside of the application core, so we are going to put it in an outgoing adapter package. Yes, that's fine. So we can implement this interface. Well, it already was there, the suggestion, implement methods. Yeah, that's fine. So now we can go and run our test again. Everything compiles. Well, now it fails. So what we can do is just make a new unicorn in our in-memory repo for now. Oh, and we need to add the identifier. Oh, how did we call it? Unicorn ID. Yeah. Let's do that and run the test. Okay, so now it's a bit of asymmetrical still, because we've only got one adapter. Usually you also have an incoming adapter, for example, some kind of controller. So let's just call this an invocable get unicorn controller, so or invocable unicorn controller, simply unicorn controller. Yes, and then we're going to implement. No, we're not going to implement. We're going to use the get unicorn use case. Okay, so let's make it as a best practice private final. And we're going to inject it there somehow, probably with Spring later on. And then we'll just make a public, well, it returns a unicorn, get unicorn. Yeah, so we're going to query the get unicorn use case for that. And we're going to put in the unicorn ID. Well, why it does not work? That's because it's a UUID. Okay. So I guess we need to still return it. Yeah. And we can see whether this thing will now build. Let's just do a clean install. Well, while that's running, we can just look now at the structure. So it passes. We've made 2 adapters, very simple ones. We've made the corresponding ports and a use case, and we've actually tested it already. So, well, this is the basics of hexagonal architecture. Everything else is really details, which you'll find in practice. So for Modulith, it's not only about hexagonal architecture. Also, Java modules play a role. So adapters can be compiled as automatic modules, and they can then be used by a runtime modular application, but they are then dependent on both the module path and the class path. So that's a way you can use modules with adapters, because they always have these horrible dependencies to technicalities. And for example, for Spring, I'm running a bit ahead now, but for Spring, it is not. It doesn't support modules. So what you can also do is compile your modules, your Maven modules, as Java modules, but run the application via a non-modular main. So that's a main Maven module, but it's not a Java module. So in that way, you just have the compile time benefits of Java modules, but you don't have the complexities of getting it to work with Spring. Yeah. So this is what I just told, actually. Let's see. We've got an example, the Unicorn app. So this is actually this is the predecessor to Bubbles, which you just saw. It had a three-layer architecture, a three-tier web app, and so what you see here are the controllers. That's of course the web layer. Then there's the application layer, and then the data layer. And what it all does together is that it gets a unicorn simply from the repository. So it's a bit more complicated, the example, because there's also another bounded context, namely a finance context. And in this example, these two contexts, well, I'll switch to the other one. This context and that one, they are decoupled via a unicorn enrichment service that uses an API and then an adapter towards the finance context. So let's just compare this three-layer architecture with two other versions, namely one refactor to hexagonal architecture and one to hexagonal architecture plus Java modules, just as an overview of how that looks like. Unicorn compare. So this is the three-tier web app. So when you look here, you immediately see the three components: the application component, or sorry, the application layer. You see the web layer and the persistence layer. And as before, we've got some manual wiring up via contexts, and we've got some common stuff that is in the common package. So that's in an overview of how it looks like, a three-tier web application. So here are the bounded contexts, and of course there are services in this three-tier architecture. So let's see, how would that look like in hexagonal architecture? Well, the contents are mostly the same, just the structure is a bit different. So now the services are still there, but they are inside the use case folder here. So, and they are a bit more fine-grained. And of course, they implement the port interfaces that are in here. Yeah, and there are the adapters. So these are the things that connect the application core to external systems. And there's also a modular variant of that here. So you see exactly the same things. You see the two bounded contexts with their respective adapter and application modules. You see a main module. So in the main module, it's just a Maven module. It's not got any module descriptor. So if we look at the application, finance application, for example, you would see a module descriptor in here. So if you just look here, you see all exports statements. So these comprise actually together the interface that it exposes. And you see some dependencies that it has. Furthermore, it's exactly the same as the variant I showed you before, the hexagonal variant. Only now we've introduced modules and we've populated the module descriptors. There was Bibbles. All right. So what are the advantages of Moduliths? Well, first off, the advantages of hexagonal architecture. It's a simple architecture. It's one of the most simple, clean architectures there is. And we saw it as a very simple package structure. Another advantage is that you can switch over adapters very easily because you can just let Spring, for example, make an instance of one adapter implementing the interface with one profile, or with another profile, you can get another adapter to implement that interface, and you can just switch it by switching the profiles. There's a strong focus on the domain because all the technical stuff you put over into the adapters. And the advantages of modules are, well, that they help you with guarding the architectural boundaries. You can do that also with ArcUnit, but it requires a lot of maintenance. This is usually a little bit less maintenance and a bit stronger modularity, to my opinion. Well, There's also testability as a major advantage. I can't go into that in detail because that would take just too much time. So more on that later. Just the main thing is actually by creating this application core and the explicit interfaces, you can very easily treat the application core as a black box, and in that way you get a situation in which you can just refactor your application core, and you don't need to refactor your tests. So that's really beneficial from a maintenance standpoint. Hexagonal architecture is an enabler. A very simple ports and adapter pattern, and with that we can separate the domain from the infrastructure, and by that practice TDD and refactoring. We can practice object-oriented design on our domain entities. We can practice DDD, domain-driven development. We can also then modularize our application along those architectural boundaries. And hexagonal architecture is therefore an enabler technology for good software development practices. Well, according to Amazon Web Services, and I won't bore you with all that stuff, but they are very lofty, and they actually say we recommend that you adopt hexagonal architecture for all your enterprise software projects, regardless of their complexity. So from a very authoritative source, that's a very clear statement. So we'll just jump to another approach now. So maybe you've heard already a bit about it. Spring Modulith. So Spring Modulith takes a different approach, and that is because hexagonal architecture does not tell us much about how to deal with multiple bounded contexts. And Spring Modulith does. It takes a strong opinion on how to handle that. And well, you see here actually what it suggests you to do. It suggests you to vertically slice your application. So there's a vertical slicing of DDD bounded contexts. And it does enforce this slicing with arc-unit rules underneath. It's highly configurable, so it's perfect for a gradual migration. You have open and close application modules, and you can define extra interfaces in the packages of your application. It facilitates an event-driven architecture. It makes it really easy to do messaging with domain messages. And it facilitates migration of this event-driven architecture to microservices via, yet again, very simple annotation, externalized. And it allows actually for any technical architecture, such as layered architecture, hexagonal architecture, onion architecture, CQRS. You can put Java modules in. It's all fine. It doesn't conflict with that. So let's look at an example of this. The Unicorn demo app. So actually, we're now going back to Bubbles. So what's under the hood with Bubbles? So when you look here, you again see this web layer, but actually now it's not a web layer anymore. So it's hexagonal. But there are the controllers again, the services. They are now a bit more fine-grained, and you've got a Unicorn repository with a little bit different implementation. So now you can just put a bit of update logic to that repository, and it actually executes it transactionally over there. So you put all those technical stuff always in the adapters with hexagonal architecture. So you can just put transactional annotations in your domain. You want the domain to be clean and pure. So again, this example is a bit more complicated in reality. So we have got another bounded context here, a magic bounded context. So we already saw it in this this example. So when we add a new leg in the unicorn bounded context, different magic abilities also are activated, and they are displayed here in this presentation. So what happens when we add a leg? So there will be a new leg obtained event. The magic bounded context receives that event. It in turn creates, when there's a magic ability activated, it creates a magic ability obtained event. And both of those events, they are received here by the walking unicorn. So that's actually the presenter in this case. That's the adapter that displays the unicorn on the screen. So we've looked at event messaging. And let's see whether we still have got time. Oh, quite a bit. Let's do a hands-on modularization example. So we've already seen how to create a hexagonal architecture. Now let's see how we can create modules. So let's see this project here. So we've already got Maven modules here, a main Maven module and a common Maven module. And here is a main module, and it has got all the rest, actually. So what we can do here, maybe we can just refactor this package to a separate module. So what we're going to do then is we're going to create a module. So let's call it unicorn application. Application, yeah, I spelled it correctly. All right, let's create this one. Oh, it already exists. Oops. Well, there's just a folder, so I'll just delete it. It doesn't clean that stuff up. All right, let's do this again. Yeah, .unicorn. Okay, let's create it. Oh no. Now there is still a module that exists, so I guess we'll have to remove that module manually. Let's see, where is it? Open module settings, unicorn application. Yeah, that's the bummer. Okay, let's create this module and hope it works now. Well, let's just first check there's not a folder there before we're doing the same thing again. Yeah. Okay, we're going to seriously. Okay, it already exists. Oh, didn't I apply it? Oh, sorry. Okay, unicorn demo. Yeah, you have to do. Oh, oh no, cancel. Can I still cancel? Ah. Okay, unicorn application, and then apply. Phew. Yeah, this always happens during presentation, of course. Okay, we can do it. Dot unicorn. Actually, I don't think it's really necessary, but anyway. Oh, okay, so now we've got a new module, unicorn application, and we can just move the unicorn application folder over there. We've got to put the base package, of course, right? So that's an open company unicorn. Let's first do that. And open company dot unicorn, and then the bounded context is unicorn. All right, and we're just going to let's get this thing out of the way. Then we're just going to grab it and place it over there. Yes, refactor. Yeah, refactor anyway. Okay. So the first thing we want to do now, we've created a Maven module, is just check that everything's working. So the modules, they are not yet in the correct order. So we've got common, which has no dependency. Then unicorn will depend on common, and then main will depend on the unicorn application. And we've also got to put these dependencies right inside the modules themselves. So let's see here. So we can move this one to unicorn application. We can make main depend on unicorn application, and then we can make unicorn application depend on the common module. Dependent, yeah, right, put it in there. Yeah, let's see. Can we compile this? Maven. Well, let's just do it without any tests. So if this succeeds, now we can add the modules. So let's just wait for that a bit. Yeah, it's finished. So we didn't make an error here. So what are we going to do? We are going to add modules. Let's first modularize the common package. So I'm just showing this to you to show that Java modules are not that scary. You can just put a module info here. Well, IntelliJ asks you to fill in the dependencies. Of course, we want that. So it's got the dependencies. Well, the ones IntelliJ thinks are the dependencies, of course. So we're going to unicorn application. We're going to do exactly the same thing here. So module info, yes, edit, fill in the module dependencies. Okay, let's see if this will compile. Oh, no, it doesn't compile. So you'll often get this. So you'll just need to walk through. So what does it say? A dependency on module common. So this is a bit strange. Sometimes this is necessary. So we've added the dependency, but we already did it. So it's here again. I'll just delete it. And for some reason now it works. It's just a weird quirk in IntelliJ. So let's go here over again and see what's now the error. Now we only need to add an export. Oh, that's just a strange thing. And now we've got in this module to add an requires. So we can do many things just in IntelliJ. You actually don't even need to know how you need to write a module descriptor. You just click on the suggestions. Yeah. Well, maybe try it again, compiling. Oh, Lombok is not visible. Okay. Yeah, it requires. Are there any more errors? Lombok, Lombok, Lombok. Oh, SLF4J. But we don't see anything for SLF4J. And here org.slf4j. So this one we can just use a suggestion. But the SLF4J, Lombok adds it. So IntelliJ doesn't really know what to do with it. So we're now in unicorn application. So we'll just do this manually. It requires, on org.slf4j. Right, and we'll try it again. Let's see. So actually it succeeds. So what we've done now is we've actually created a compile time, two compile time modules. Now common is a Java module and unicorn application is a Java module. So we can also now run the build with tests and then we can just check if everything works correctly. And just I don't know if there are integration tests. I need to kill that unicorn. They are already extinct, except this one, and I just killed it. Okay. And if it succeeds, I guess we still have time to finish the presentation. Just in time. Yeah. So, luckily. All right. Let's move on. So, migrating to the Modulith. Let's do a recap. The Modulith is a modular monolith. And what would be a best practices approach to migrating from a monolith to a modulith? Well, the first thing I would suggest is building a safety net. Before you're going to do any refactoring, just build a safety net with acceptance tests, which might be integration tests. Do a gradual untangling of the vertical slices or bounded contexts. You can do that very well with Spring Modulith. It allows a very gradual refactoring. Then you can untangle and decouple further and put proper APIs in place. Then implement an hexagonal architecture, modularize along the architectural boundaries, and then you can create and run unit tests against those APIs. When you've done that, you're actually free then to refactor inside your application module. You can implement DDD, you can use a rich domain model. You're free to make your application better. So what to choose? That's actually up to you. Would you like to know more about hexagonal architecture and TDD in combination with TDD? Well, next year we're going to organize a meetup. So if you'd like to, let your badge be scanned when leaving this room, and we'll keep you up to date. Thank you for your attention. And if there are any more questions, we still have a little bit of time left.